This section is on unit vectors and it's section 20B of the textbook and part 2. We can change the length of a vector by multiplying it by a scalar or just a constant number. To find the length of a vector, we know that we take the square root of the first component squared plus the second component squared. So if we have a vector, say a1i plus a2j or a1, a2 in column form, then the length of this vector is a square root of a1 squared plus a2 squared. Sometimes the length is called magnitude or sometimes even modulus depending on the textbook. We're going to explore this a little more in the build-up to unit vectors. So let's say we have vector A, and that's 3i plus 4j. We're going to find its magnitude. So the square root of 3 squared plus 4 squared. And when we simplify this, this will just become 5. The magnitude is always going to be positive. For vector B, this is 2 times vector A, right? 2 times 3i plus 4j. Now the length of this vector is really just going to be double the length of A, or 2 times the length of A, which was 5. So the length of this vector equals 10. Now you can also do this the long way by multiplying the 2 through the vector. So 2 times 3 is 6i plus 2 times 4 is 8j, and then doing the same thing by then taking 6 squared plus 8 squared and taking the square root of all of that, and you'll get the answer is 10. So you can do this 2 ways. If we sketch 3i plus 4j, we go 3 across and then 4 up. And for vector B, this is when expanded 6i plus 8j, so we go 6 across and 8 up. Notice that this indeed does look like B is double the length of A. For our next one, I think you know what's going to happen. If we have half times 3i plus 4j, this is really half of vector A. So the length of vector C will be half times the length of vector A. So that will be half of 5 or 2.5. Again, you might like to just expand C, so it would be 3 over 2i plus, or 4 over 2 is 2j. Take your components, square them, and take the square root. If you do it this way, you should also get 2.5. And your diagram should match up to this. Lastly, this is an interesting one. We've got to find the length of D, where D is minus a half of our vector A. So if we do this by expanding first, we would get that D is equal to minus 3 on 2i minus 2j. And I'll just sketch this here. It's in the opposite direction of our vectors, and it's actually in the opposite direction, but the same length as vector C. So even though D has a negative constant, we should find that the modulus or the length of D is a positive. So if we take minus 3 over 2 squared plus negative 2 squared, we do get a positive number, and it's 2.5. So that's the catch when multiplying by a negative scalar of minus a half times vector A. This is really just a half of the length of vector A, which is 2.5. So the negative doesn't affect the length of the vector. Your length of your vector will always be positive, but it just indicates that your vector is in the opposite direction of the original. Notice all of these vectors are parallel to one another, and indeed they all lie on top of each other in the way that we've drawn them. So the question is, what scalar should we multiply the vector 3i plus 4j by to make its length equal to 1 unit? Here's the best way to think about it. Imagine we have a Python vector. And if you have a killer Python at home, you can feel free to do this activity. We're going to call this Python vector OP, where O is the base of the vector or base of the Python, and P can be the tip of the Python's head. What you can do if you have one is you can measure out the Python if you extend it. Now in our case, we know the length of this Python in the diagram is about 20 centimeters. Now, what we want to do with units vectors is shrink your Python so that we create a new vector in the same direction as your Python, but instead of its length being 20 units, I want its length to only be 1 unit long. In other words, what constants should you multiply OP by to shrink this vector so that it becomes 1 unit in length? It's really just going to turn from a killer Python into maybe a sour worm. We're going to call this new shrunk vector, vector OM. Hopefully you've had a thought about it. So if we multiply our vector OP by 1 over 20, or split it up, imagine, into 20 different sections, each section would now be 1 unit long. Okay, so if I times 1/20th by OP, the length of this vector, 120 times OP, will simply be 120 times the length of OP, which was 20 units. So 1 over 20 times 20 is 1. In this way, I've created a new unit vector that's 1 centimeter or 1 unit long in the same direction as OP. So that is the vector 1 over the length of OP times OP. And that will be our unit vector OM. Make sure you write down this formula somewhere. So if we have a vector A1I plus A2J, a unit vector is a vector in the same direction as the original, and its length is just shrunk or extended to 1 unit long. So if we have A, then we can say its unit vector U, sometimes also known as U hat, is equal to 1 over the modulus or the magnitude of A times vector A itself. And that little hat symbol just indicates unit vector. Here are some examples. Find the unit vectors in the same direction as. First one, V equals 6i minus 8j. So to find V hat, or the unit vector of V, we take 1 divided by the length of vector V and times this by vector V itself. The magnitude of V, that will just be the square root of 100 or 10. So the unit vector in the same direction as V, but with only length 1 unit, will be 1/10 times our vector V, 6i minus 8j. For B, vector W is equal to minus I plus 2j. Again, we're going to find the unit vector in the direction of W. So this time we have the length of W, well, that will just be the square root of minus 1 squared plus 2 squared, which is just the square root of 5. So we know W hat is 1 over root 5 times vector W minus 1i plus 2j. If you wanted to write this in column form, you can. The unit vector of W would just be minus 1 root 5 over 2 root 5. And that occurs just by expanding and putting the 1 over root 5 inside your brackets. Let's try this with 3D. The same process actually applies. If we have vector A is equal to 1i plus root 2j minus root 6k. To find the unit vector, we just take 1 over the length of vector A times vector A itself. Now, the length of vector A, you just square each component, add them together, and take the square root. So we'll have 1 squared plus root 2 squared plus minus root 6 squared, and take the square root of that, which is actually 3. So we know the length of vector A is 3. The unit vector is 1 over 3 times our original vector, I plus root 2j minus root 6k. If you took the length of this vector, okay, by expanding the 1/3 in, and then squaring each component, summing them together, and taking the square root like usual, you should get that the length of your unit vector is 1. That's how you know you are correct. Find a unit vector in the opposite direction to C, where C is the vector 4i plus 3j. So we know a unit vector in the same direction as 4i plus 3j. That would be 1 over 5, because the length of 4i plus 3j, we did that earlier. And we times this by 4i plus 3j. So this is a unit vector in the same direction of A, but we want a unit vector with the opposite direction of A. So we take our unit vector. To get it in the opposite direction, we just put a minus sign out the front. So this is a unit vector that is still parallel to A, but just in the opposite direction. And this is my final piece of wisdom that I leave you with for 20B.